and welcome to another episode of Tech and Test with me, Peter Johnson. Today we have Casey Rosenthal. Casey, welcome to Tech and Test.
Hi, thank you so much. It's my pleasure to be here, Peter.
Great. Do you want to introduce yourselves or you to the Tech and Test audience? So we know you as the chaos engineering guy. Do you want to expand a little bit on that for someone who doesn't know what chaos engineering is?
Sure. So chaos engineering is a practice born out of distributed systems at scale that kind of can't go down. Those tend to be very chaotic. And so chaos engineering was a practice to improve availability specifically for those systems and engineer your way around the chaos. So that's where the name comes from. Generally I'm known as the chaos engineering guy. I developed the practice at Netflix. My background is in systems at scale and the infrastructure for the hyperscalers, mostly with a focus on availability.
Awesome. So I guess what problems did you face at Netflix to kind of go, right, we need to really tackle, come up with chaos engineering? Because to me, it feels like a lot of organizations have a sort of testing or DevOps or testing department, or maybe testing is built into development. So why did, or even SREs, right? When you start getting to larger Google-sized companies, you tend to have teams of SREs to make sure things are all operational. So where did the idea of kind of interjecting a whole different methodology for approaching systems, and what was the impetus that triggered this approach?
Yeah, so in the early and mid-teens, Netflix was doing a lot of interesting things, and the organizationally, the way they were set up was kind of a nice cauldron to ferment some new practices, many of which have parallels in the broader community under different names. So, for example, a lot of the DevOps stuff grew up also at Netflix, but under different names. Now, when I joined Netflix, they already had a tool called Chaos Monkey. Right. And in fact, they were already using the word chaos engineering. It was just a bit more vague. So Netflix was really the first company to operate on the cloud at scale. Mm-hmm. And so as a pioneer for AWS, they had done things that other companies hadn't done. They'd also faced problems that other companies hadn't faced. And in the early days, they had a lot of outages. Their availability kind of just sucked. And again, at the time, AWS was introducing auto scaling, and that had all sorts of issues. They like to joke that a feature of the cloud at the time was that instances would spontaneously disappear. And when that happened, when an instance would just disappear or VM would collapse, Netflix would often go down. So because of how, and this is why I mentioned Netflix's organization, because of how Netflix was set up as an organization, there wasn't a CTO or a chief architect who could say, okay, this is a technical problem. We're going to find a technical solution, and then everybody has to implement it. They just didn't have a role to enforce that kind of structure. Instead, it was more like a few dozen teams owned a bunch of services, and they were all racing to improve the services in parallel at the same time. So again, in the early teens, this DevOps and frequent deploys. Netflix was already doing this. Netflix already had a microservice architecture. Mm-hmm. But it had this problem. So how do you solve a problem of an instance goes down and the whole system stops working? So they tried a bunch of things, and the thing that worked was Chaos Monkey. So Chaos Monkey would kind of list all of the services every day, and for each service, it would randomly choose an instance, and it would shut it down during business hours every day. So if you worked on one of those teams, you couldn't deliver any feature unless you solved this problem first. So all of a sudden, it took the problem that the organization needed to solve, clearly defined it, and put it right in front of the engineers.
Mm.
And that very quickly solved the problem. And Netflix hasn't had an outage due to an instance disappearing since. So they wrote blog posts about it, and they kind of popularized it, and it got a kind of an edgy reputation as like, oh, Netflix shuts its own instances down on purpose just to, be rough and tough. And that's one way to look at it. I think the more useful way to interpret it is they found tooling to highly align all the engineers towards one goal by putting the consequences directly in front of them. And once engineers have a clearly defined problem, hey, they solve it. That's what engineers do. So a few years went by. I was hired into kind of an availability role, managing the traffic team, and my boss at the time had a charter for a chaos engineering team. And I had just started, and he said, "Why don't you make something out of that? We have Chaos Monkey. Like, we should do more things like that." And so I went around the company and said, "What is chaos engineering?" And the answer I usually got back was, "Oh, that's when we break stuff in production," which sounds really cool. But I'm pretty sure I could break stuff in production all day long, and like nobody would thank me for it. And I wanted to keep my job. So I asked around kind of the broader community in Silicon Valley at the time, and didn't get any really good answers. So instead, we literally sat down in a conference room, and I spent the better part of a month borrowing from resilience engineering some well-developed theories and concepts that just hadn't been applied to software before. And we wrote the Principles of Chaos, which we posted online at principlesofchaos.org. And so we defined a practice with a gold standard, and here's how you start, and here's what we're trying to do, and here's what you're looking for, and the kind of some of the why behind it. And that was the start of chaos engineering. Yeah, I mean, a couple of things that were interesting to me about that. I love this line of work, the availability stuff, because it's just full of these things that feel super intuitive, but the research shows us are just completely wrong. And this is really true of safety. So availability and cybersecurity are usually how these two things show up in the tech world. So for example, you think like, oh, well, if we just get really good at documentation and run books, that'll make our system safer. Nope.
Right.
If we put guardrails on everything and get rid of all the sharp edges, that'll make systems safer. Nope. There's a good dozen things that, like, when you say them, they sound like they make sense. And then you look at the practice and the results of people trying to implement those programs, and we have the data that say, no, those things aren't true. And resilience engineering, which was born from a nuclear 3 Mile Island, a nuclear incident here in the late 70s in Pennsylvania. We've got 40 going on 50 years of research on how to run large scale critical systems in a safe way. And so, we've people who have looked at nuclear power plants, aircraft carriers, air traffic control, railroad routing, shipping lanes. There's a lot of study there. And for the most part, software is just kind of blind to that area of research. Like there hasn't been much overlap. So it's a really rich field to go like explore there and see what they're doing, and then bring some of those lessons back to software. And a lot of them have been just incredibly enlightening and extremely helpful in practice. So that was the start of chaos engineering. And then there were a couple of quirks to Netflix that kind of led to the growth of the discipline as a practice. but those are other Netflix isms.
I see. Yeah, it's interesting. So bringing in a new kind of way of working or a new kind of system, right? The biggest thing I'm thinking of is if a lot of companies shut down their services, and especially if you're monetizing of some of these services, how do you get senior management to buy in to this is a good idea? Because if they're saying, well, no, you can't do that because we could lose 10% of our traffic, which essentially could could be revenue, right? So I was interested in how basically management were on board with this idea of bringing down services deliberately to improve engineering practice and resilience in sort of longer term. How do you sort of trade that with a very sort of capitalist organization that's really willing to make sure there's no downtime at all, right?
Yeah, I mean, no downtime at all is just impractical when it comes to the internet because of the last mile. But things that are outside of the control of the organization or the company. But it's a great question, and most information and talks about chaos engineering focus on the fault injection aspect of it, like shutting an instance down or cutting something or purposely disrupting it. The practice itself is a practice of experimentation. So not everything is fault injection or failure processing. But we'll get back. Let's just assume that most of it is. So again, because of a Netflixism, and that's kind of a different story, we had to start evangelizing chaos engineering. So I called up kind of the usual suspects in Silicon Valley at the time. So Facebook, LinkedIn, Amazon, Uber, these kinds of companies. I don't know, Fang Plus. And I just found people who are doing similar things or who are in similar positions, like responsible for availability or, had similar roles. And I brought them together for a day where we were just going to, openly share stories about our failures and what we're doing to remediate them. And I called it the first Chaos Community Day. First one was in San Francisco. And it was great. And we found that a lot of people were doing similar things to what we were doing at Netflix. And so I would say like, that just call that chaos engineering. It's like close enough to what we're doing. And so we could evangelize it that way. So the first year, I think there was ING and maybe another bank or two. And, afterwards I was like, so what'd you think? And they were like, well, yeah, it's interesting, but like, entertainment, social media, ads, like, you're talking about experimenting with live traffic. We could never do that. We're a regulated industry. Like it's not possible. And I said, okay, well, so do you still have outages? Oh yeah, of course we have outages.
Right.
Okay, well, we're offering here, we found a way that has, reduced our outages, or it's certainly increased our understanding of the complex system and allowed us to optimize for what we want, whether that's reduced outages or shorter, less downtime or faster feature, et cetera, whatever. So I guess you could just keep running into that brick wall, falling down, getting up, running blindly into the next brick wall, or you could try this and, have a little flashlight. Maybe you see the brick wall before you run into it. And that started to gain traction. Now, the last time I spoke with someone at Gartner a couple of years ago, they said about 80% of the large banks here in the US have a dedicated chaos engineering program. So either by philosophical convincing or by just pragmatic practice, that took hold. The interesting thing to me, though, was the following year, when some of the banks had started, ING was actually leveraging chaos engineering internally for resources, resource allocation by the next year, and some other banks were starting to look at it. Capital One does a lot of great stuff with the chaos engineering now. But the second year we did Chaos Community Day, we invited some healthcare companies, and they kind of did the same thing, looking down their nose at us like, oh, entertainment, dollars. We have lives on the line. Like we can't be doing this.
Right.
And that was a great moment for me because I said, look, we based the practice on Popperian Western notions of science. The pinnacle of which is the double-blind clinical trial. You guys already do chaos engineering. You just call it something different.
Right.
And it's like, oh yeah, okay, yeah, I guess we do. It's like, yeah, you experiment in production with lives on the line all the time. In fact, you guys made it, a universal practice. So yeah, so then we started to see, and now we see a lot of health insurance companies in particular, but a lot of healthcare companies have a chaos engineering program. Again, the point of it isn't to introduce chaos. The assumption is that you've got a complex system, meaning your services grow so big, your technical architecture, your infrastructure, everything is so big,
yeah,
that no one person can mentally model how all of the pieces fit together. And once you get to that point, you have to do something different than testing. Because testing requires that somebody can understands the inputs and outputs and how the system is supposed to behave.
Yeah.
And experimentation, the success that the West has had with experimentation has been like, oh, I think it works this way. Let me see if I can prove it doesn't. I can't prove it doesn't, so I'm just going to keep thinking it works this way. And then occasionally, oh, no, it doesn't work the way I thought. You learn something new. Great. That's what pushed Western science forward. Testing doesn't really, that's not the purpose of testing. Whereas experimentation, that is the purpose. So healthcare now has also kind of, embraced it. And a lot of large, heavily regulated companies run chaos engineering as part of just part of normal operations. Not everybody does it in production. There's certainly a wide variance in sophistication in terms of like how well integrated it is into tooling or feedback to engineers or into their DevOps processes. There's a very wide distribution of maturity and adoption. But I haven't seen anywhere that it can't work.
So let's say I'm a small startup, right? We have 2 founders, we have 10 software engineers, and we've built some application. We have a few customers starting to onboard with our application. At what point within this journey, should I start considering chaos engineering, or what are some basic steps, or what is the first thing I should start doing to kind of adopt this practice and to kind of prepare for when my systems get larger?
I would say the moment that you think a safety effect, like an outage or a security incident, could make the news and damage your business, is a good litmus test for an executive. For a technical team, the moment that you no longer have somebody who can mentally model the system, you should probably start thinking of something similar to chaos engineering, if not actually just a full-blown program for it. To give an example, say you've got, I don't know, a new AI thing that analyzes, I don't know, music for something, and you build a Rails app and it does some processing and gives some feedback. I think Rails is well understood.
Yeah.
By Rails engineers. It's the fact that it's a convention over configuration framework even leans into that bit. So, I wouldn't necessarily describe that as a complex system.
Yeah.
And there's competitive forces, so you got to allocate your time reasonably. So in that case, I would like put QA on testing, and I mean, really, I'd focus on product development and customer feedback.
Yeah.
Um, yeah. So I mean, you need. I mean, yeah. So then there's the complexity of the application and the dependencies and the different things that are interacting to make this to make the product. And then there's scale, right? Like at least in theory, if your app is stateless, um, Django, Rails, whatever node, whatever you're writing in, if that's stateless, and then you've got a good separation with the state layer, um, you can just drop in more stateless applications and scale it horizontally. Um, that kind of thing doesn't really trigger like complex system in my mind.
Mm-hmm.
But again, if you get to the point where it's like an outage is potentially fundamentally or a potential existential threat to your business, well, then you should address that. And that's
Yeah.
that's where chaos engineering was born, to address that kind of challenge.
I see. Okay. So chaos engineering in the sense of like a small startup running a Django app, let's say, what would that look like in terms of tooling and process and practice? What would an engineer in that team think about when they think about chaos engineering?
Yeah, again, like that. I think that's not the ideal scenario
Yeah.
for like a full program, but for like dipping your toes into it, it would be okay. In particular, if it's Django, I would say you're running it on Postgres, or you've got like RabbitMQ for running for a queue or something like that. It would be
Mm-hmm.
like, okay, well, what happens when Postgres starts slowing down? Or if you've got multi-node configuration for your database, what happens when it drops a node? Or same for RabbitMQ. Yeah, and the experiments would be looking for how does that manifest in the customer experience. Now, again, because a Django app is pretty much a simple system,
Yeah.
I would discourage the kind of experiment where you have confidence that like, oh, if I turn Postgres off, everything stops working. Okay, well then you don't need to run. Don't run an experiment. Go fix that. It's more for like, okay, I have a peer database set up or some load balancing for the database, and my expectation is if I lose this node, things will keep working fine.
Yeah.
That's a good experiment. So your assumption, your hypothesis is that under these conditions, customers will still have a good time. And that's my favorite framing for experiments. Under condition X, customers still have a good time. And then like run an experiment to disprove it, and hopefully you don't disprove it. So that's kind of like that would be a well-informed one. And again, with a small team, I probably wouldn't automate that. I would probably just do that as a like a game day in like a war room during business hours when everybody's available in case something doesn't go as planned. You've got like all hands on deck.
Cool. Yeah, that makes a lot of sense. Like, I remember working in some organizations where it wasn't a very complex system, right? I think we had some Kinesis there, but we did have to think about, okay, if Kinesis does go down, or we've got bigger problems, but like, it's more, I guess, more from a testing perspective. I guess we're thinking of like, how does the system behave with that state, right? If there's no connection to Kinesis, what happens to the rest of the system? Does it reconnect? Does it, if this is an ephemeral drop in connection, or if there's already messages that have been half processed, and sort of testing our own business logic with that scenario. Yeah. But I guess the intention here is, say it was a much more complicated system, then it'd be like, okay, if that connection drops, there's another one coming to play, like a backup system that would still give the user the same experience. So in this case, it would have been someone would have got an alert and would have had to like check out what had actually happened. So in that case, I guess there's less experimentation, right? Because it's more, okay, service has gone down, problem.
Yeah. Like when I give conference talks on this, I like to put up a map that we made of Netflix services, because it's like you can imagine like hundreds of services that are talking to each other, and just looking at all the request responses go through the system, it's just evident, like visually evident, that no human could understand what's happening. And even if they could, every day these systems are being updated by the teams responsible for it. So everything's changing, everything's in motion. And so you imagine a request coming into Netflix, and it's like, okay, first it has to get through all the AWS infrastructure, DNS, load balancers, hits a server. Now it's probably running on a container platform, so it's there's another level of abstraction there, and then there's a reverse proxy to parse the request, route it to a different service, which might get some customer data, some user data on you, which is another service, and then bring that back, and then pass the request down for a geolocation service, and then hit, and on and on and on, before eventually whatever an HTML or XML response or JSON gets emitted back. So it's we could spend a long time talking about all the different layers that it goes through, and all those different layers are generally owned by different teams. So like that's the kind of place where people who are in chaos engineering programs and kind of live it, I can't imagine not doing this, because it's like there's nobody who knows all of this. And what we need to make sure is like, okay, if that Cassandra database with Redis in front of it, if Redis goes down and it's using Cassandra as a fallback, that customers still have a good time. Our assumption is yes. But like we need to verify that. And so there's tooling to in place at sophisticated companies like Netflix to minimize the blast radius, so that you can get very, very good control over, like, okay, we're not bringing all of Netflix down if something goes awry, but for a very small selection of either synthetic traffic or production traffic, if we have high confidence, we will, sever that connection and allow those requests to be served from the database, or inject latency, or drop packets. And generally those are the things that you would do for a microservice architecture or a big distributed system. And then we'll watch when the requests are emitted back to the user, like, are they okay? Does the customer still have a good time? And like that, the infrastructure to build that kind of a tool takes time to develop. But oh my God, once you have it, there's so many cool things you can do. And then feeding that level of information back to the people who operate those services is eye-opening, because like there's no other way that the person running that Redis cache could know without actually seeing an experiment with empirical data from production, right? Like they can guess all day long, but I've one of the types of stories I collect are stories where it's evident that a failure happened with conditions where there's no way that sitting down your best engineers in a room and saying, imagine all the things that go wrong, they would never think of this way that things went wrong. And it's not because they aren't smart. They might be the best engineers in the world, but it's just like you can't know that unless you actually try it.
Right. Yeah. Because you've got certain traffic patterns of behavior, and certain systems going offline in a certain sequence, which may have triggered that particular thing, which you can't always do all of that. Even if you use some AI generated traffic, profile that somehow works.
Especially if you use AI. Yeah. I mean, like, so some of my favorite examples are when you have remediation steps or automation in place and it doesn't anticipate the business case or the behavior of other remediation stuff that's in place. And a retry storm is a perfect example of this. Like, you're having usually the device retry the request as a remediation path, right? But then if you don't control the retries or the rates, and or worse, if you have a signal that's telling it to retry stronger, then you create a retry storm that ends up bringing down the service that you're trying to make more reliable. Again, on the other side of things, I've seen systems that one of my favorite failure patterns on the server side are systems that try to optimize for availability and cost. And if a server starts doing too little work, will be shut down. It'll auto scale down. Combined with a pattern where if a server gets too much work, it will circuit break and start returning like default responses or stuff from cache instead of actually calculating it, which immediately drops the CPU load. So then it's doing a lot less work. So the system goes, oh, you're doing less work, we don't need you, gets rid of it, which spikes the traffic for the remaining nodes. So they fall back down into circuit breaker mode, which is a lot less work. So then they get shut off. And so you've got this race to shut the service off because, I mean, again, you can, when you're designing the individual components, it totally makes sense you're going to auto scale down. Totally makes sense that you're going to have a circuit breaker pattern. These are good ideas. But when you put everything in total, you just can't anticipate that they might not play well together the way you would hope they would.
Definitely. Yeah. And even the testing doesn't really cover those kind of scenarios, right? I
don't very difficult to test that. Yeah.
Yeah. I think it's a case of, right, let's just, even if you have a staging environment, it's really rare people tend to do these kind of tests in a testing context, right? Or a testing mindset. So, because you need the production level of traffic, I think, sometimes to even get some of those scenarios that you're talking about.
Sometimes, totally. Sometimes you need a lot of traffic. Sometimes it's just having all of the pieces play together. Well, one of the distinctions that I make between testing and, because I think chaos engineering belongs under the umbrella of QA, so it's in the same arena as testing. They're both under that umbrella, I think. But one of the distinctions that I try to make for people is in testing, you're making an assertion about the valence of something, of a system property that you already know. So the engineer has to say, given these circumstances, it will behave this way, true or false. Versus experimentation, again, you're saying, I think the world works this way. And then I'm just going to see if I can prove that wrong. And when you prove it wrong, often you're discovering a completely new property of the system.
Yeah.
So in the former case, the engineer has to understand what they're testing. In the latter case, you don't. You don't really have to. It's gonna, if it's rigorous enough, you'll learn new things about how the system runs. So that's one of the big difference. The other big difference I see is as a I'll call myself a recovering engineer, but as a former engineer, there's this propensity to dive into the code.
Yeah.
Right. So if there's a problem or a bug, you want to dig in and see how it's, and you're trying to verify that the model or validate that the model operates the way you think it does. Does this code do what I think it does? And again, chaos engineering and continuous verification, which is also a broader umbrella, they don't really care about that. They're looking more at the system behavior, and it's, as long as the system is producing the outcome that you want, the business doesn't really care if it's doing it the way that you think it is. Um, or another way to say that is like you don't have to know how the pieces work or what's happening inside. Or there's an expression here in the States that you don't have to know how the sausage is made. You don't have to know what's going on there
Yeah.
if you like the output. So again, like testing, you can dive in and validate the components, and in experimentation, you're verifying system behaviors. And you may have no idea how it works, or it may work completely different than how you know. But like, as long as the output is pretty much what you want, then you're going to move on to something else.
I see. And I think that's fundamentally maybe why we get buy-in from management, right? Because if the business output is still what we want, if we're Netflix, we want people to stream videos, right? So we want low downtime across all geographic regions. So if we find a system that can keep that running, we don't care what bit of code does that, as long as it's doing it efficiently.
Yeah.
Where the engineering mindset is, no, we need to test this bit of code because this service is supposed to be, this codecs, there's all these other things that we need to worry about. They need to be doing the right things. And I think it's the difference between sort of systems thinking versus sort of building up a kind of the responsibility thing of which responsibility do you own? And engineering teams tend to own small bits of the puzzle. So they tend to own service or a few services, and they would make sure those services work. They don't really care if it doesn't work end to end or not, because that's kind of either there's another test team doing that, or another team's doing some integration testing, or they're doing some integration testing, but there's no one really always testing this stuff in production, right? And putting the levers and checking what actually happens. So I think I can see why we care about chaos engineering and why it's so important, and we need to, it's almost bringing it right back to the business case of like, the system still needs to deliver. We don't care how you've made it, what you've built. The service needs to operate. So it's kind of coming from that angle, I think, which, I can see why, as a business owner or, someone responsible for reliability, that you'd actually care about these things.
Yeah. But it could also be super frustrating to an engineer. I mean, like, it's easier for us to think deterministically, and like, there's nothing more frustrating. Well, I'm sure there's not much more frustrating when you're testing something than a non-deterministic failure, right? Like, that is super frustrating. In chaos engineering, that's like gold, because that's like, okay, there's obviously something happening here that we don't understand. And understanding that is going to inform so much other stuff that we do from an availability perspective. The more we find of those, the more successful chaos engineering is. So yeah, it's definitely a perspective shift, and it definitely leans more towards the business case and kind of an executive, I don't know, perspective. I will say, in the early days in particular, most chaos engineering programs were embraced by headline grabbing failures. So for Netflix, it was Christmas 2012 was part of their engineering culture. US East 1 went down, Christmas Eve, and they had like almost a 24-hour outage due to a region being down. And that was like the worst thing for Netflix, because the promise of the service at the time was, you have all of your in-laws over. Don't worry, you don't have to talk to them. You can just sit around and stare at a screen and share space without having to interact. And Netflix is down. Now you have to talk to your in-laws. So that kind of got ingrained into, and so they did put a lot of resources into a program they called Chaos Kong, which was, Chaos Monkey did instances. Chaos Kong will do regional failures, which was the impetus for funding eventually the dedicated chaos engineering team. A lot of companies have an outage like that inspired we can't have that again. Never again. How do we solve this problem? Okay, chaos engineering is one of the ways that we could proactively address it. Let's do that. And I think that's also one of the differences between like continuous verification and testing. Continuous verification and chaos engineering as kind of a subheading of that are proactive, both pragmatically and in theory. Like that was one of the purpose of developing them. Whereas almost every other business practice around availability or outage reduction is reactive. So if you look at disaster recovery, incident response, incident management, testing to the extent that it's focused on availability. Almost all of the industry practices up until the point of chaos engineering were reactive. They all happen after the outage. Right. And again, even testing was usually like, oh, we've had this kind of failure before. Let's put a test in place, and we'll do defense in depth. We'll just keep adding tests for outages that we've seen before. And so chaos engineering was a way, and continuous verification was a way to say, no. Let's proactively paint the landscape for the people operating this infrastructure at scale, so that they know what could happen. And again, I think that's the eye opener that the industry hasn't really embraced yet. Like if you're operating a piece of infrastructure at scale, Kubernetes, like Kafka is everybody runs Kafka, right? At scale. So I'll pick on Kafka for a second. If you have the best observability in the world for your Kafka stack, you know how many requests it's handling, you know what it's doing right now. You still have no idea if you're standing on solid ground or the edge of a cliff. And by and large, a lot of the theory that we borrowed from resilience engineering for continuous verification is that if engineers know they're about to step off a cliff, they'll do something. Like, and you have examples of this, like in economics and workload. If you like, nobody has a rule you can't spin up 1 million instances at AWS. Why? Because everybody knows like that would cost so much money, like you'd be out of business, right? So like you don't need that rule. Engineers just automatically do the right thing. Unless you have a case of sabotage, and that's exceedingly rare. So the same is true for availability. If engineers knew that doing XYZ would prevent an outage, absolutely they would do it. The reason we have incidents is because they don't know they're about to have an outage. So going back to that Kafka hypothetical situation, what if I were to tell you, like, okay, right now you've got 1,000 requests per second. Where your cluster starts to strain is at 10,000 requests per second, and this many concurrent connections, and this payload size, and this much latency between brokers. Like, then I can like paint a picture for you of what your safety margin is. And you can decide like, oh crap, like we're about to fall off the edge of a cliff, or like, oh, we're safe for as much growth as we could foresee for the next 10 years. There's very little tooling right now out there that will paint that picture for people, even at some of the most sophisticated hyperscalers. Certainly on the market, there's like, it's really difficult to find a vendor who has a solution that could be out of the box modified to work on in kind of like the homogeneous infrastructure environments that we see across, like, I don't know, the Fortune 500, for example. But if you put yourself in the shoes of the people monitoring and operating that infrastructure at scale, like, my God, it's night and day. Like if you go from great observability stack to oh, I'm getting this daily update of like where I sit compared to like where stuff starts getting bad, and I know that my safety margin is this big, don't ever take that away. Right? Like
Yeah. But I
that's
get, is the answer you have to just spend a lot of time building these tooling in house? If you're one of those hyperscalers that we can't afford to go blind. We need to build this, right? Is that the answer?
I mean, it's part of the answer, and eventually there should be vendor tool. I mean, yeah. I mean, in full disclosure, one of the reasons that I'm working at the company I'm working at now is because they have tooling that does some of this,
Right. Okay.
and they do it repeatedly at a bunch of companies, so they can start to develop pieces of tools that are easier to pull together. But the large companies themselves, they really need to push this forward too. And there's this really interesting phenomena in IT where security and availability are two sides of the same coin. They're both system safety. And security, say you have a big security breach, the next day the budget goes up for buying vendor tools.
Yeah.
Like you're buying tooling, and you're going to be chronically understaffed, but you're buying tools. In availability, you have a big outage, the opposite happens. And I don't know why historically this is the case, but it is what it is. The opposite happens. You get budget to hire more SREs or more availability teams, and no money is set aside for tooling. And so, like I've done some studies on like SRE implementations. A lot of them fail. A lot of the principles behind SRE that worked at Google could only work at Google. Because other companies don't have 10% of their workforce that was experienced enough and bored enough to embed in teams and just work on reliability. So part of this is the industry has to change to build this kind of tooling, and also to seek out this kind of tooling and go like, oh, we've got availability issues. Let's find some vendors. Let's either build it in-house or find some vendors who can give us this type of insight that I'm describing, where the operators can go, okay, I've got a safety margin, and it's either acceptable or it's not. But now I know what my safety margin is. Right now, almost everybody is flying blind. And that's a technical problem. Like that can be solved. That can be fixed. And the acceleration of AI makes it worse. So
that was going to be my question with like, how does AI fit into the picture? Because now we've got, a whole bunch of people who may want to vibe code something up and may not be a software engineer. They may just know enough to piece together an application, right? But in general, there's going to be more applications developed and more people pushing things. And I'd hate to be putting my credit card details in some of these vibe coded apps, but in general, it's a case of I just think AI, we've got more models and more things that could go wrong, right? Because you're potentially using more compute. And if you don't have the observability piece solved in terms of how much, am I going to run out of memory if the next customer does something with that model? Could that break? I mean, I remember, I don't want to call out anyone, but I remember ChatGPT, when they first sort of launched, there was a lot of outages and downtime with, users just quickly trying to use it, because there was like millions of users accessing it in the first week. And there was a lot of availability issues there. And a lot of that, I guess, was just all hands on deck, getting things working, I imagine. But if you were doing some chaos engineering then, you may have been able to predict what level of service we could offer, right?
Yeah, I mean, I have yet to figure out who at OpenAI is doing chaos engineering. If anybody, they absolutely should have a program at the size that they're at. So if anybody here knows, have them hit me up. I would love to swap notes. But I think AI introduces two interesting things from continuous verification perspective and a chaos engineering perspective. One of them is that they're non-deterministic systems. So you introduce chaos engineering, you introduce AI or generative AI. I think you automatically have a complex system now because, and you're still dealing with, like, in the case of availability, usually what you're talking about is trust with the end user.
Mm-hmm.
And now you've added another dimension to that where the output, the generated output could potentially destroy trust with the end user. So you really need to think about it systemically, and you need to be running experiments like this to get the confidence internally that under these conditions, customers still have a good time. So that's an interesting part of it. I think the other phenomena that I'm really curious about is, we saw a couple of weeks ago an MIT study, or months ago, an MIT study saying that 95% of generative AI programs are failures. There's no return on that investment. Which I believe is related to this phenomena where in software engineering, when you give experienced software engineers AI tooling and AI fluency, they're more productive. When you give junior software engineers AI tooling and attempt to give them AI fluency, they're less productive. Why is that? Well, it seems like if you use AI to save you typing, great, you can move faster, but you need the experience to be able to determine when it's giving you the code that you want and when it's not. And if you're a junior engineer, you don't necessarily have that intuition. And so you can move faster down the wrong path. And there's less checkpoints for somebody more senior to come in and see what you're doing. Go, no, that's. And in fact, it encourages, the way Gen AI works, it encourages you to keep using it to move faster in the wrong direction. So I don't know of any other tool that's been introduced that actually increases the disparity of productivity between senior and junior people. Usually a tool like allows juniors to catch up, or everybody goes up, or there's some sort of convergence. This like opposite effect, I don't know that we really have. I don't know that we even know how to like train people. Like, how do you train a junior engineer to the point where they can use AI effectively if giving them the tool itself is going to make them worse?
Yeah, it's a valid point.
I have no idea what to do, but the end result, like you said, is like you've got the stuff that's vibe coded, where you could have something that looks like a mature product that completely doesn't work under the hood. And again, like that's the kind of thing that you should really be running experiments on to make sure that the thing gives you the output you expect it to.
But you need to know what the output is, right? Like, well. So
that requires judgment, and
and there are some organizations, exactly, senior and experienced, someone who's been in that position before and goes, I've deployed a whole bunch of these apps and I know the security footprint and profile we're aiming for, right? And vibe coding kind of takes some of that away depending on who's using it. Which is kind of your point. So one thing I'm sort of just thinking about with generative AI and people using it is we've got like some large organizations and CEOs saying, big numbers of people or big numbers of percentages of code are generated now by generative AI. Loads of CEOs have actively said this, publicly. And I guess my concern is anyone actually tracking downtime now? So has downtime increased as a consequence of more, or have there been more incidents, right, as a consequence of having more generative AI generated code? Like, you could have 20% of your code which is written by generative AI, but now you've got 2 or 3 times more incidents than you would have had before. So I don't know if anyone's
Well,
tracking that.
I mean, there's a couple interesting things about that. One is like, okay, if I'm writing some code and like I get 3 or 4 characters in and then hit tab and it fills in the other 80, like, okay, does that count as,
Yeah.
95% of my code is now written by Gen AI? Probably that's the closest thing I could imagine to them actually tracking, right? Like there's no way that they actually have accurate tracking. But if
No.
they did, they're probably doing something like that. So like, is that really I mean, tab completion, I
Mm.
I don't know. So I'd be very skeptical of like the numbers that like Salesforce, for example, is giving. And if you have data to disprove me, I would love to see it. I would love to see that and dig into that. But I'm very skeptical of how high those numbers are. But behind that, any experienced engineer knows that lines of code is a terrible metric for for anything in software development, except maybe lines of code removed, which we all like. Um, so so uh, so I'm not sure if there's much of value to get from those executive statements about like, oh, look, we're embracing AI. Again, the MIT study and other anecdotal stuff and the research that's going on seems to indicate that like, no, this is not the productivity booster that people think it is. There's never going to be a good way to measure like availability or downtime, even within an organization, let alone across the organization. One of the things that we find is improvements in reliability tend to be eaten by feature velocity.
Mm.
So, and this is mostly a outcome of being in a competitive market. So if you've got a product and somebody else comes up with a similar product and you've got some reliability issues and you fix them, once they're fixed, generally your team's going to start pumping out new features faster, and that
Right.
would probably exacerbate the kinds of issues that would put reliability pressures on them again. So it's like a dance of like, okay, I make it more reliable. Okay, now I can get these features done. So like feature velocity usually eats reliability. So generally, like and that might be part of the problem why resource allocation for reliability and for uptime is not well understood at the executive level, because you can't it like it you're probably not getting the outcome that you want if you say like, oh yes, our business went up to whatever 5 nines of uptime. um you say that one quarter, great. You say the same the second quarter, okay. Say the third quarter, why are we still giving you money? That's
Yeah.
what it was 2 quarters ago. Like,
Right.
you did your thing, you're done, right? Like, so it kind of
Yeah.
needs that tension of like, okay, now we're and it takes a certain experience as an executive to be able to explain like this investment in reliability led to these features hitting customers like
Mm.
faster. Like that, I mean, that's not intuitively obvious, but like that's probably the best outcome for a business in a competitive market.
Right. Yeah. Yeah, that makes sense. Because if you have the whole engineering team going, we're too scared to ship this feature in production, we're dealing with the current outages that we've had over the weekend. We'll get
Exactly.
we'll get to that feature, but hang on a minute. uh,
Exactly.
so yeah, I think point made.
Or, oh, we can't deploy on Fridays, or we can't deploy outside this window, or
Yeah.
like we can't deploy like any of those. Anytime you hear that, it's like, okay, literally the lack of reliability of your system is logically delaying your feature velocity.
Mm.
If you fix that reliability, your feature velocity goes up. But it's where are you going to invest your time? Mm. There's always business context to make it go one way or the other.
Yep. And typically it's, new features, customers want new features. new features for, like you said, to be competitive in the market, right? I'm sure all the big companies are looking at what their competitors are doing and going, oh, we need to do the same now. So yeah, I think that just drives people just to focus on shipping code, rather than constantly reassessing the impact of reliability, because we've just added a whole bunch of new code, and hopefully most of it is not generative AI generated as well. So you've got that into the mix as well, because that if that's if there's no guardrails around that code, and I'm not always sure code reviews always pick up on these things, because if you're looking at something I have about code reviews, I remember when I was working at Google, my first change list, as they called them there, was many hundreds of lines. I think it was like 200 or 300 lines of code, and immediately got closed by someone in YouTube. He was like, "No, 100 lines only for this change list, right?" There are other reasons of why you'd want to do that, because there's other programs like Readability to sort of say, I can code in this language. Here's an example change list. But I think most of it is ingrained into the engineering culture that you keep your code small and readable, and people can understand it. But typically,
I think, yeah. Sorry, if I could interject, I think there's another reason to keep it small, and that's reversibility.
Powerful.
So yeah, so the biggest thing that you can do architecturally to make your system more reliable is to make the system as reversible as possible. So a small change is much easier to undo than a big change. And whether or not a person understands it or not might be ancillary to that. But again, like, you can invest in CI, CD tooling that, if the process of putting something in front of a customer and changing your mind as an engineer is super reliable, then you will deliver features so much faster.
Yes, definitely. Because you don't have to live in fear, right, of the feature going wrong. And some of this should be covered by experimentation, right? So you should be able to experiment with your features in production with a smaller group of customers, and hopefully get some feedback on, does that actually work? Were we getting the metrics we expected? If not, then at least we haven't committed all of the traffic to this experiment. So there are some guardrails around that, which can kind of help. But if you start, shipping code and seeing drops in things, you may go, we may not want to. We have a choice. We can just stop reverting traffic to that particular feature. So sometimes that happens, but that's not always at a developer level that those decisions are made, right? They're often made typically with more stakeholders involved who are looking, and you've got data analysis people involved looking at data, and so it all gets a bit more complicated in the sense of, it's not just you're able to revert a commit and you're done. It's usually packaged under something like an experiment that has some particular goals associated with it. But you're right. I think the smaller the change you're making, the more controlled that experiment can be. If you're changing something in UX and you're seeing what's the impact of that, do you get more click rate, or do you get more leads, or you can kind of track that better. It's almost like keeping the experiment small and controllable. And same with code, I guess, right? If you're making a very big change, you're doing some new integration with some other tool, or new database integration, whatever it is. I think keeping things small and doing things incrementally are better, because then you can always go back and go, well, this didn't quite work. We can scrap it.
And I got my eyes were opened to focusing on reversibility from Kent Beck. And he talks about this a lot with even now with tidy programming and the stuff that he's working on. But it's that being able to make an incremental change, and this is really behind the original XP concepts and TDD, being able to make a decision and get feedback right away, and change your mind. And it's that last part. Anything you can do to optimize that pays dividends down the road. So like, if again, like if you're if you're an engineer, like CI was a huge boon here. Almost everybody does that. CD, a good chunk of the industry is already there. I think CV, continuous verification, is kind of like, or at least should be kind of the next step in that evolution. But feature flags, blue-green deployments, automated canaries, like you can actually sit down and invest in tooling and infrastructure that improves reversibility that will pay dividends down the line. And so when I talk to different tech teams about like, well, what can I do to make stuff more reliable? There are things that you can just sit down and go like, that does that improve reversibility? Yes, do that. Like that, it's nothing's a slam dunk or silver bullet, but it is an easy kind of metric, or I don't know, area of focus to go like, I know I'm going to make an improvement here if I'm improving the process of, again, an engineer saying, I'm going to do something this way, get it in front of a customer. Nope, change my mind. And, get that from a month down to 5 minutes. Yeah, that's a different team. Right? You're building different products. That's completely different, right? And you were at Google. You've seen systems that can do that.
Yeah.
And most people don't have those systems. So just imagine what the state of software could be like if everybody had those systems.
Yeah, it is surprising when you see like when a company's invested so heavily in a whole bunch of tools, and some of these tools go into testing even, right, and other disciplines within software engineering. But it is like, wow, a lot of these problems are solved, right? But for the average organization that isn't your Google, because I think the thing is with a lot of these large organizations, people read books on like how Google tests software and other practices they want to adopt, like you mentioned with the SRE cyber liability processes that Google have. They don't always apply to every org, right? You don't always want to be like Google because you don't have their scale of traffic, and like you said, you don't have the same scale of engineering teams working there on building the tooling and having that 20% extra time that they could think about what tools they want to build. So you kind of have to approach the problem different. And also, let's be honest, right? A lot of organizations don't have the same, capital to spend on this, especially if you're a small startup, trying to build something. You want to spend those dollars on building features, right? So, it's and don't forget, it's very publicized, right? Google Web Server was very unreliable when the team first built it, and that influenced a lot of their processes around testing. And so the reason they're very test heavy, and that's often part of the onboarding process to make sure everyone follows testing, is because of the pain and the downtime they've had very early on when they started building the first web server. So, yeah.
Yep.
So, yeah, it's kind of going back to your point with once you've had an incident and it's in the news, you then start spending money on these things.
Yeah. And some companies have been around long enough that they have the perspective to do it before they're in the news or in the news again.
Yeah, they've been in the news before. They don't want to be in the news again. Casey, thank you so much for coming on Second Test and for...
Oh, Peter, it was a pleasure.
Yeah. I've learned so much from you about chaos engineering, and I'm sure a lot of people will. And if anyone's interested in learning more about chaos engineering and deepening the discussion and the depths, what should they do? Where should they reach you, or what resources would you recommend?
I mean, obviously read the book. So sorry. So I wrote the O'Reilly book on it.
Cool.
But I mean, that philosophically, that's a good place to start. There's I am sometimes asked by engineers or department heads, like, what do we need to do to get our team ready for chaos engineering? great thing is like it's not a skill set. It's just a perspective and a time allocation. If you're a software engineer, you can do chaos engineering. It's just whether or not you decide to spend your time doing these things or not. Starting from, you know, a simple game day to, you know, building sophisticated tooling that's constantly running experiments in the background. So yeah, there's you know, Google will come up with a lot of options there. The book is kind of a systemic review of some of the FANG companies and how they did things and why, and then kind of goes through like the philosophy of like, okay, why are we looking at complex systems in this way, and what can we do to proactively mitigate some of the aberrant outcomes that we'd like to avoid. Yeah, and then just, you know, if you're interested in talking more, hit me up. I'm pretty easy to find online, and I love talking about this stuff. So,
Awesome. Thank you so much.
thank you. This was great.